Hello, everybody. A warm welcome from my side from Berlin. I'm today again with my friend Zane, and hand over to you. Say about something.
Yeah, hi everyone. My name is Zane. I work in the Netcool Development Lab based out of London.
Today we're going to talk to you about Watson AIOps, and specifically we want to talk about a installation detail that we have in the event manager piece. So all these red circles are the topics of today. Today we're talking about how to get data into our system. So how to get gazillions of events from various systems into a centrally installed object server that will be running on our OpenShift environment, and then all the rest will come with probe rules files, with object server correlations, impact policies, UIs, and so on and so on. But that's not part of the video of today. Today, we're going to talk about what are the possibilities that we have when we do architecturing our solutions. So typically, we have three possibilities in here. So we can install everything on our local installation. That's something we call on-premise installation. We have a local data center, and we have a lot of bare metal machines or VM machines, and we install everything there. The other possibility is we are going to install all and everything into an OpenShift environment that can be hosted, for example, on the IBM Cloud. So we have in another video how to install exactly this kind of environment into an IBM Cloud ROCs environment. Have a look in there how to do it. And we are going to talk about today how to enhance this kind of environment with locally installed probes, how to get locally installed probes connected to object servers that run in the OpenShift cloud. That's the topic of today. And that's exactly where Zane is going to take over and showing it how to really do it. Zane, all yours.
Thanks, Fred. Could you just back up to that last slide?
Sure.
Okay, so what we're going to look at today is connecting probes that are on-premise into the object server virtual pair that is sitting inside OpenShift. There's two sort of deployment scenarios here. One is where you have OpenShift running in your own data center, and one is where you are running it on a cloud environment, for example, IBM's Cloud. So we're going to look at two scenarios. The first one involves connecting the probes directly to the exposed object server, what we call node ports. This doesn't require any specific configuration. It just requires finding out what those ports are and connecting them. And the second one is a little bit more complex, and that is where we want to connect our probes to the object server over an SSL connection. So this is a little bit more configuration because obviously there are certificates to set up and save and configure and so on. Now, if you're deploying the event manager onto IBM's cloud, the hosted OpenShift environment, only the encrypted connection is possible. So this is where we'll look at that one. Okay.
That's a very good point.
Yep. Okay, so now let me share my screen. So we're going to start with this, this page, which is the Knowledge Center documentation for connecting event sources to Netcool Operations Insight, also known as Event Manager, on a cloud deployment. Okay, so we'll start with the simplest case, connecting to the object server node port. So let's say you've got your OpenShift cluster running in your data center. By default, the configuration has two exposed ports, which allow connection to the object server directly. These are called node ports. And the instructions here are relatively straightforward. It's basically finding out what the node ports are and then configuring your probe to connect to them. So we'll walk through that procedure now quickly. Here we are logged into our OpenShift UI, and what we're going to do is connect to the console. So I'll click on here, open the command line tools, and copy the login command. So what this does is it brings up a login token so that I can log into my cluster. So this always takes a little while to come up.
Hit the escape button.
Click it again.
And then hit again display token. Here we are.
Here we go.
This is how I do it.
Yeah, so copy your login command and paste it into your terminal window. So now we're connected to my OpenShift cluster. What we will do is go back to the documentation, and we're going to find out what ports our object servers are exposing to the outside of the cluster, to which our probes can connect. So the first thing we're going to do is get the release name of the primary aggregation object server. And we're going to use the primary aggregation object server as our model, but you can just do the same thing with the backup object server in the same way. So the first thing we're going to do is list the service details for our primary aggregation object server. In my case, my namespace is an NOI. I hit that, and it comes back. I have to change the release name to match my release name, which is NOI. I run the command, and it tells me the external port that my object server is running on. I can see it here. So in this particular case, you can see that the primary port is exposed on port 3212 in the example, in the demo, in the documentation, but 32170 is my exposed port in the outside world. And I can test this by telnetting to the hostname and to this port. The next step is to do the same thing for the backup.
Can you use NCO ping as well?
Yes, you should be able to, yep. So if I do the same thing for my backup, you can see I've got a second port, so it's the same host, but the second port will be 32704. So finally, we will find out what our the host name is for our system, and we will just use those details in the fourth step here to configure the omni.dat file. Primary is your host name of your cluster, and then the port number, that node port there, 32170. And then the backup will be the same host name, but with 32704 as the port number. Does that make sense?
Yes, very.
Okay.
It seems far too easy. There must be a trick.
So now we move to where we want to create a secure connection, an encrypted connection to the object server. Now this could be a requirement, a security requirement of our organization, but it may also be where we have deployed NOI or Event Manager onto IBM's hosted OpenShift environment, in which case.
And this is now going more into a production type environment with everything encrypted.
Right, and also considering that this data, this traffic is going to go over the internet from your data center to a cloud environment, it's probably a good practice anyway to have your environment, your events flowing over an encrypted link. Ah,
I can see you have the new model and activated in here. I can see this baselining graph.
Yeah.
This is cool. This will be part of another video.
Yeah. So I need to, another video is how to enable this. There's a few steps.
And how to use it.
Yeah. So let's go back here. So we pick up here, we say, okay, so now we're going to look at the connection, making an SSL connection to our object server. So this one has a few more steps. It's in the same area of the documentation, but this time we're going to connect to the proxy node port. So what we're going to do is we are going to set up an SSL connection to the NOI proxy, which is running in the deployment via SSL, and then that connection is automatically relayed to the object server running inside the cluster. So the first step to do that is to identify the proxy's listening port. Because what we will do is we will configure a connection from the probe to the proxy, and then what happens in the background is that data is then passed over to the object server's node port in the background. This is what we will be configuring today. So the first thing to do is identify what port the NOI proxy is actually listening on. We will walk through these instructions step by step. So what we're going to do first is get the service details for our proxy. In my case, clear the screen. In my case, my proxy is called NOI-proxy. So I'm going to type the command now, OC or kube control, get service minus output YAML, NOI-proxy, namespace is NOI. So what you can see here, based on the information in the example on the documentation, you can see this piece of information that we're after is this ports information at the bottom. So we can see that the node port or the proxy port for the aggregation object server is 30132, and the port for the backup aggregation object server via the NOI proxy is 31545. Now these ports support encrypted data connections. So the next steps is to actually configure the TLS encryption. What it says to do is to make a note of these two port numbers. So we'll make a note of 30132 and 31545. Just write those down myself. Okay, we move on to the next step, configuring TLS encryption with Red Hat OpenShift. So this is where we need to identify our cluster's master, find out which certificate we need to retrieve, and set up the TLS connection. So the first step is to ensure that connection can be made to the cluster master node. Where OCP master address is resolvable network address for the cluster master node, for example, and it's got a URL there. So in our case, we're going to be connecting to the host name, which is provided by our cluster. So if we go to the IBM Cloud UI, we can see what our cluster name is here, right? So copy that. And then what we will do is we will use this address in order to ping this master address. So ping that host name, and you can see it's coming back with an IP address there, 52.
Oh. So this is a locally executed ping, which pings your stuff in the OpenShift cloud of IBM.
Yeah, so this is the primary IP address is used to access my cluster.
Would you have to consider local proxy setups for more customer type setups? Because usually customers do have proxies in their environments. They do not have direct internet access.
Yes, perhaps. And also you have to be able to use ping or something like NSLookup, for example. You could also do it with NSLookup to find out what the IP address is for that. Oops. So let's try that NSLookup, and we put the host name, and it comes back with the address as well.
Which means it is resolvable. Cool.
Yeah, and you can see it's the same IP address anyway. So NSLookup, ping, either one is fine. Okay, so we're going to use this information and the port number that we copied earlier to now try to identify the location of our proxy, and we're going to use that to acquire the certificate. So we move on to step 2, and we're going to follow this command here: open SSL s_client -connect, and we're going to use the OCP master address, and we're going to connect to this proxy port 30132 in my case. So this is the port number that we copied down in the last step. Okay, so now this has connected and it's pulled back all the data. The certificate data relating to this particular endpoint, which is my cluster, followed my port. And as you can see in the example, we're looking for the line on line 0, which is giving me the common name. Is that what CN stands for? I think so. Giving us the common name for our proxy server. We need to make a note of this. It's called noi-proxy. It's basically your release name followed by -proxy.noi.svc in my case. So we make a note of that. This is the common name of the certificate that's presented by this particular proxy server. Right, so make a note of this common name before we move on to step 3. Right, in step 3, we're now going to get the certificate, the public certificate from this source. And we use that using the OC command again. So I'm just going to copy and paste this I've just made make a temporary directory. So I'm now in a temporary directory. I'm going to run the command, and I'm going to get hold of the cluster certificate itself. I'm going to download it from the source. So OC get secrets signing key in OpenShift controller, and all this whole command, and we're going to copy that and paste it into our terminal window and get a copy of the certificate. Now, because I'm logged into my cluster already, it knows which cluster to connect to, right?
Makes it simple.
Yeah, so I've now got a copy of the certificate. I've now got I know what the common name is for my proxy, and I know my port. So I'm collecting all the various pieces of information, including the certificate. So the next step is to ping my proxy common name command. If this command fails because it cannot be resolved, it's because this name noi-proxy.noi.svc is not known to DNS or your local machine. But what you can do is simply add an entry to your hosts file with this name, so that when it tries to work out who noi-proxy is, it actually resolves to an IP address. So what I'm going to do is just tail my etc hosts file, because I've set this up earlier. You can see our address, which I worked out earlier from the ping command or the nslookup command. I've got the host name for my cluster, and I've added the common name for my proxy here, noi-proxy.noi.svc. Okay, so now I should be able to ping that common name. This is important because when it looks at the certificate, when it attempts to make a connection, it needs to be able to actually identify that fully qualified domain name and map it to an IP address. So as you can see, I can successfully ping my proxy's common name. Right, we move on to step number 5. This next step is where we import the certificate that we downloaded earlier into our key store. And what we're going to do is we're going to install this key or this certificate into our omnibus installation where our probes are located. And by virtue of installing this certificate into our key store, it basically tells the system this is a trusted system. Even though it's not an officially signed certificate, it is to be trusted for connections. And this is an important step before the probe will be able to connect using this certificate. To do this, we need to make sure that we have a keys file. And the easiest way to do that is to run this command. In my case, I already have this file. So I've got the file there. But what we're going to do is we're going to use this command to import the file, or we can just run this command from the command line to create the file if we don't already have one. But this application, NCI Keyman, this allows us to actually manage our key manager. So I'm going to be connecting my probe from my local machine, so I'll run this here, and I want to import the certificate here. To do that, okay, so you can use the GUI-based key manager here, or you can just run this command here to create the file via the command line. In my case, I just ran the command, so I found that easier. Once you've generated your key store, we want to import the certificate into that key store. Okay, so now that we've created our key store in step 5A, step 5B involves importing the certificate that we downloaded earlier, that we saved earlier. So I've got my certificate cluster-ca.cert.pem, and basically you just use this command to import that certificate into your key store. Once you've done that, the certificate will be safely stored in your key store, and the probes will actually then see this destination as a trusted source.
So it's a handshake we're going to establish.
Yeah. So rather than trying to connect to my cluster's proxy port, receive an unsigned certificate, which will fail, it now knows that this cluster is trusted, or this is a trusted destination. The last step is to edit our interfaces file.
We need to amend these server settings.
Yeah, the last step is to add an entry to our interfaces file. So as you can see here, I have added 2 entries to my interfaces file, ZaneRoxP and ZaneRoxB. And what I'm going to use as the connection name is the name of the proxy common name. As you can see from the documentation here, the proxy common name. In my case, it's noi-proxy.noi.svc. The key piece of information here is this SSL, right?
Yeah, so it's encrypted, and the port number.
That's right, yes. And then finally, the port number that we have written down earlier. So I can create a primary entry, a backup entry, and then I could create a virtual pair as well in the normal way.
And then you need to create the interface file again.
Right. So then we run the command nchome bin nco_igen, and now we should be able to ping our object servers. So Zane roxp server available and Zane roxp.
Yeah.
Right. The final step is to test it. So we're now going to switch to our probes directory, and we're going to
simnet.
We're going to attempt to run the simnet probe. Server is going to be Zane roxp. I'm going to switch on my message level to be debug and my message log to be standard out. As you can see, there's a lot of information in there about connecting to the. I'll just stop that probe, and we'll go back and take a look at what the initial communications with the server. Right. So now, if I scroll back in the probe rules, the probe log, you can see that the communications with the object server. You can see it's connecting to Zane roxp. And if we scroll down a bit further, you can see that it is detected that this is a HTTPS or an encrypted connection. So it's attempting to load the TDS module. And further down, you can see you can see here it's loading all the protocols relating to making a secure connection with the object server. So TLS connection messages here. You can see it pulling the certificate information down. And you can see eventually a successful connection to the object server.
Where is it?
So it says here, Zane roxp is a primary object server polling the table. So now it's made the connection and off it goes. And then you can see it's sending me simnet events.
Yeah.
If I switch over to my system now, I should be able to see some events in here coming from my simnet probe. So let's just scroll down.
And you possibly have set up a specific filter which is filtering on the simnet probe class.
Yeah. So you can coming from all my links here. There's a simnet event there. AX01 is all the link.
Go on information.
Yeah.
Just select one information,
and
you can prove it's coming from the simnet probe.
Yeah, there's the class there.
Cool.
Okay, so in summary, we've covered how to connect our probe to the object server node port, right, for just a standard unencrypted connection. And then we moved on to cover how we import the certificate and set up our machine, our probe machine, to make a secure connection, an encrypted connection to our object server via the event manager's proxy service. So thanks everyone for watching.
So thank you, Zane. That was really impressive. I've never done it before and really need to try it out this day. So now I can connect my local probes to my OCP-based object servers. And that's exactly what all our customers want to do as soon as they are playing with the OpenShift setup. You can find in the front page also the contact details of Zane and me. If there's anything you need to know, just give us a ring. And with that, I would love to thank you for your attention. If you want to see something different in another video, just let us know. These kind of videos are very easy to record and very easy to publish for us. So give us a ring, give us a message, a text, whatever kind of connection you want to choose. And with that, I wish you a very nice day. Thank you very much.